Hello everyone and welcome to the part 3 of this series of physical geography in which we are covering the physical geography NCERT of class 11th. And in the previous two videos we have covered up to the landforms part. If you haven't watched these videos, go and watch them also. So now in this video we are going to start with the atmosphere and climate. What is atmosphere? So it is the composition of gases, dust particles and water vapor held to the earth's surface by the gravity. So as gravity is the major force that is keeping the atmosphere intact, so the heavier particles must be near the surface of the earth and the lighter particles will be in the upper atmosphere. So the density of the atmosphere near the surface of earth will be more, and as we move away from the surface of the earth, the density of the atmosphere will be decreasing. So now let us have a look at what are these gases which comprises of atmosphere. So the major gases: nitrogen, which is around 78%. Then comes oxygen, which is around 21%. Argon is around 0.9%. Carbon dioxide in 0.036%. Now these neon, helium, krypton, xenon, hydrogen, these are also present in trace amounts. Now comes the dust particle. So what all comes under these dust particle? Smoke, soil particle, ashes, and the disintegrated disintegrated rock fragments, pollens, etc. And why they are important? Because they act as a hygroscopic nuclei. That is, they provide the surface to the water vapor to condense, and due to which the rainfall happens. So now these dust particles are majorly concentrated in the subtropical and temperate region. Subtropical and temperate region, they have more amount of dust particle than the equatorial and polar climate. Why? Because the air here in the subtropical and temperate region is dry. Now comes the water vapor part. So water vapor can be 0% by volume of air in arid region, and it can go up to the 4% in the wet climates. It is a major component of the atmosphere because it prevents the temperature of earth from getting too hot and either becoming too cold. How come this? As the water vapor absorbs the incoming solar radiation, and it also prevents the out radiation of the earth's surface to escape the atmosphere of earth to maintain its temperature. Now let us look at how these concentration of water vapor varies. So from equator to poles, the concentration of the water vapor decreases, and the water vapor also plays an important role in the stability and instability in the atmosphere. Stability and instability. Suppose if a parcel of air, it does not contains the water vapor, that is, and it is warmed, and this air uplifts, so it does not have moisture which will condense and form the rain, so it will settle down to its own place, creating the stable situations. And if a parcel of air is saturated and it has more water, then it will rise in the air, condenses, form the cloud, and rainfall will happen, so it will create a situation of instability. Now how can we measure this water vapor, that what is the amount of water vapor in the atmosphere? So it is known as humidity. And how it is measured? It is measured in terms of absolute humidity and relative humidity. Absolute humidity is the actual amount of water vapor that is present in the atmosphere, and relative humidity is the amount of water vapor that is present in the parcel of air upon the maximum amount of water vapor that the parcel can hold. So this relative humidity also changes with temperature. As the capacity of the air to hold the moisture increases with the temperature, so this relative humidity is also affected by this, which is more over the oceans, less over the continents. And if a air parcel contains the moisture to its fullest capacity, it is known as saturated. And the temperature at which a air mass becomes saturated, it is known as dew point. It is also the same point at which the condensation starts happening. And what are the various forms of condensation? There is dew, mist, fog, and frost. So dew is the moisture deposited in form of water droplets on a cold surface like blades of grasses, plants, stones, etc. And ideal condition for this dew to form is clear sky, calm air, high relative humidity, cold and long nights. And it is necessary that the dew point is above freezing point. And if the dew point is less than the freezing point, then the condensation will held in form of frost. That is, small layer of ice will be formed on the cold surface. And the conditions that are required to form the frost are same as of dew. For the mist and fog, when the temperature of an air mass drops all of a sudden, and there are presence of hygroscopic nuclei which helps in the condensation, then the fog is formed near the ground. It is major phenomena observed in the industrial areas where the high amount of hygroscopic nuclei is present, and when this fog is mixed with the smoke, it will result in phenomena of smog. And mist is also similar, but this fog held in a less moist condition, and this happens mist occur when the moisture is higher. Moisture is higher. So now as a result of condensation, the clouds are formed. So now let us have a look at types of cloud. So based on their shape and height, the clouds are divided into different types. For example, cirrus cloud, they are high clouds, which are thin and feathery in appearance and white in color. Cumulus clouds, they are like they have feather-like structure and generally formed at a height of 4 to 7 kilometers. Stratus, stratus clouds, these are in shapes of this. Strata means layers. And nimbus are generally the name for rain bearing cloud. So based on their heights, these cirrus, stratus and cumulus clouds are also divided into different types. For example, high clouds, they are cirrus, cirrostratus, cirrocumulus. Now middle height cloud are denoted by the prefix alto. So these clouds are altocumulus and altostratus. And low heighted clouds are stratocumulus and nimbostratus. And these cumulonimbus clouds are generally formed during the tropical cyclones, and they have high vertical extent, and they are known for the torrential rainfalls. When the condensation is taking place inside the cloud, and the weight of the water particles present here becomes heavier, and it overcomes the resistance of this cloud. So it starts falling down under the influence of gravity, which is known as precipitation. Now it can be of different types, like rainfall, where water droplets are falling, known as hailstorms, where the raindrops are solidified in form of ice in concentric layers, and hails. The precipitation happen in form of hailstorms. Another one is sleet, in which the raindrops are solidified to the ice form, but they are not condensed and take the form of hails, but they precipitate in form of feathery ice crystals. Now let us look at the types of rainfall. First one being convectional rainfall, which take place due to the phenomena of convection. That is, hot air rises, condenses, and rainfall happens. This is the convectional rainfall. Second one is orographic rainfall. That is, if a moisture laden wind is moving and it would strikes a barrier, that is mountain or a highland, then it rises up and condenses air, and rainfall is happening on this windward side of mountain, and this leeward side of mountain, it does not witness rainfall, and it is known as the rain shadow zone of the. Another one is cyclonic rainfall. We will study this when we will be studying the tropical and temperate cyclones. Now, how is rainfall distributed? So generally it is more on the coastal areas and lesser in the interior of the earth's surface, and the extent of rainfall is more in the equatorial and tropical regions. Now moving back to the atmosphere. Now let us look at the structure of the atmosphere. Atmosphere is divided into five layers, which is troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So all the climatic activities are generally confined to this layer of troposphere. This is the lowermost layer of the atmosphere, extending up to a height of generally 13 kilometers, which is maximum at equator, which extends up to around 18 kilometers, and at poles it is lower up to 8 kilometers only. So the troposphere is structure of troposphere is like this. It has slanting in nature, and why its height is more on the equator, because of the high convective cycles, because the heat received on the equator is more, so the air rises up to a greater height, and in the poles the sunlight is limited, so the air rises up to a limited height, and the temperature in the troposphere decreases with the height, which is known as lapse rate. What is a normal lapse rate? It is 6.5 degree Celsius per 1 kilometer, and temperature here over the equator goes up to minus 80 degrees Celsius, and over the poles it is minus 45 degrees Celsius. And this layer between the troposphere and stratosphere is known as tropopause, and here the temperature is generally constant. So you can see this in this chart that the temperature is decreasing as we're moving upwards. In the stratosphere, we witness the ozone layer, which protects us from UV rays. So due to presence of this ozone layer and absorption of UV rays, the temperature of this stratosphere increases with the height. So, and this is the layer suitable for the flying of aircrafts. It extends up to the height of 50 kilometers. Then comes the stratopause, which is the transition zone between stratosphere and mesosphere. Here the temperature is also constant. And in the mesosphere, which extends up to a height of 80 kilometers, the temperature again start decreasing with the height. It witnesses the coldest temperature. Now comes the mesopause, which is the transition zone between the thermosphere and mesosphere. Here the temperature is also constant. Then comes the thermosphere, which is also known as ionosphere, because there are free ions that are present in this layer, which reflects back the radio waves, and it is also important for the radio wave communication. So in this thermosphere, the temperature again start increasing with the height. And then after 400 kilometers, then comes the exosphere, which is the last division of the atmosphere, and its limit is up to the space. Now let us look at the elements of the atmosphere. What are these? This is temperature, pressure, wind, humidity, and precipitation. We have seen this, and climate. Now starting with the temperature. Starting with temperature. So what is the major source of temperature of the earth? It is solar energy, which comes in form of short wavelength, and these incoming solar radiation in short are termed as insolation. On an average, the energy received by earth is 1.94 calories per centimeter square per minute. How does this insolation varies on the surface of earth during day and night during various seasons? So major regions are rotation of the earth. As earth is rotating on its axis, one part of the earth is sunlit at one time and another half is dark. So this region is witnessing more insolation and this is not witnessing. After the rotation, this part will be witnessing more insolation and this part will not be witnessing. Now second point is the angle of inclination of sun rays. So earth is tilted on its axis. Now the point where the sun rays are oblique, that is slanted rays, they cover the more area, due to which the energy of the sun spreads to a more area and the insolation to a particular area reduces. And where the direct sun rays are falling, there the insolation is more. So the higher latitude witness lesser insolation and the low latitude witness high insolation. Next one is composition or transparency of the atmosphere. Atmosphere composition. For example, there is more cloud covers, then sunlight will not be reaching the surface of the earth, so insolation will be less. And if there are more gases which absorb the UV radiations, then the insolation will also be reduced. Now the insolation received at the surface of the earth varies from tropics to the poles. In the tropical region, it is around 320 watt per meter square. And in the poles, it is minimum, which is 70 watt per meter square. Now, how does these short wavelengths increases the temperature of Earth's surface? So, as Earth act as a black body, first thing is that it absorbs all the radiations and emit back what it absorbs. So the processes involved in the increase of heating and cooling are conduction, which is helpful in increasing the temperature of the earth air masses near the earth's surface. Convection, this help in increasing the vertical temperature. Convective cycles are hot air rises, then moves and subducts. Another one is advection, that is horizontal movement of air, which causes the temperature distribution. Now the earth absorbs these incoming short wavelengths and radiate it back in form of long wavelengths. Our atmosphere is not heated by these incoming short wavelengths, but it is heated by these outgoing long wavelength radiations, because the atmosphere is transparent to this incoming solar radiation, that is it passes through it, and it is opaque to these long wavelength radiation, that is it stops and absorbs these, due to which the temperature of atmosphere increases. Now let us have a look at the heat budget of the atmosphere. This incoming solar radiation is total 100%, out of which 6% is scattered to space, -6, and 17% is directly absorbed by the earth's surface. And this 34% is moving across through the clouds and absorbed by the earth's surface, and 27% this is reflected by clouds back to the space, and 2% is directly reflected by the earth's surface to the outer space. Why? Because of the albedo effect. And this remaining 14% is directly absorbed by the atmosphere. Now the total amount that is absorbed by the earth's surface is this 17 plus 34 plus 14, which is equals to 65%. Now this has to be radiated back to the earth's space. Out of this 65, 14 is absorbed by atmosphere and 51% by earth's surface. So earth has to radiate back this 51%. Now how does earth does this? 23% are radiated from earth, 9% in form of turbulence and convections, and 19 by form of conduction. So this is how the earth maintains its heat budget and maintains its temperature. Now insolation is the incoming solar radiation, and it increases or decreases the temperature of the earth's surface. So this temperature is the measure of hotness or coldness of a area. So what are the factors affecting this temperature on a earth's surface? So it is, first one is latitudes, that is insolation is varied according to different latitudes. So in the same manner the temperature is dependent on the insolation. Second one is altitude. With the increase in the altitude the temperature decreases. Distance from the sea, distance from sea has a moderating effect on the temperature, and the range of temperature that is diurnal or seasonal is minimum near the sea. So the internal parts of a continent have more temperature differences. Another one is movement of air mass, such as a cold air mass is moving through an area, then the temperature of that area will be cold, and if a warm air mass is moving through it, then the temperature will be warm. Second, one, one, two, three, four. Fifth one is presence of ocean currents. It is also directly proportional that if there is cold current, the temperature will be cold, and if the warm current is present, then the temperature is more. Next one is presence of land mass, and so the land is heated faster, it heats faster and cools down faster. That is, water takes time to heat up and also cool down. Now, what is isotherms? These are the lines that are joining the places having the same temperature. For example, 20-degree isotherm, 30-degree isotherm, like this. So in January, in the North Atlantic Ocean, the isotherms over the oceans bend towards north, and over the continent isotherms bend towards the south. And why over the oceans they bend towards the north? Because of the presence of warm ocean currents. And in the this phenomenon is in northern hemisphere, and in southern hemisphere the landmass is less and the extent of ocean is vast. So these isotherms are generally parallel to the latitudes. There is less deviation in the isotherms. For example, 20 degrees Celsius isotherm, it runs parallel to 35 degrees south. 10 degrees Celsius isotherm, it moves parallel to 45 degrees south, and 0 degree Celsius isotherm, it moves parallel to the 60 degree south latitude. And July also, the isotherms generally keeps parallel to the latitudes. There is also a phenomena of which is known as inversion of temperature. Generally, we know that with increase in the elevation, the temperature decreases at the normal rate of at normal lapse rate, which is 6.5 degrees Celsius per 1 kilometer. Now, if the temperature start increasing with the height, then it is known as inversion of temperature. It generally happens in the winter times, which leads to the fog formation. And as the cold surface is covered by the hot air and the temperature is increasing upwards, so this leads to creation of stability in the atmosphere. That is, air will not rise, and air dust particles suspended will create the collision phenomena of haze, and visibility will be reduced. And such phenomena are witnessed in winter in Delhi every year. Now moving on to the next element, which is pressure. So the air around us has some weight and it exerts pressure in every direction against everything it touches. So this pressure is known as atmospheric pressure, which is measured in the unit which is known as ATM or millibar. What is the normal atmospheric pressure? It is 1013.2 millibars. Anything higher than this is high pressure, and lower than this is low pressure. And the difference in the pressure is the major cause of movement of air. That is, air moves from high pressure to low pressure areas. How does this pressure varies? It is direct inversely proportional to the temperature. Area having high temperature will have low pressure, and area having low temperature will have high pressure. And with altitude, the pressure decreases. The pressure is direct inversely proportional to the elevation, and generally it is this decreases around 1 millibar per 10 meter. And the line which is joining the areas having the same pressure is known as isobars. Now let us have a look at the pressure distribution on the Earth's surface. This is equator, 10 degree north, 10 degrees south. So this is equatorial low pressure zone. Why? Because the temperature here is high and the convection is more, so the pressure will be less. Then comes the subtropical high belt. So the air which rises from here, it moves in the both direction, and it subducts here, which creates the high pressure. This is known as subtropical high pressure belt. Thereafter comes the subpolar low, subpolar low pressure. Air rises from here, moves in both direction, and subducts here and at the polar areas, and this is polar high. So there are these four pressure areas: equatorial low pressure, subtropical high pressure, subpolar low pressure, and polar high pressure zones. So the isobars also move in the different seasons. So in the northern hemisphere, in winter time, they will move southwards, and in summer they will move northward. Why? Because in the summer time, the sun will be here in the northern hemisphere, and the temperature here will be more, so the pressure will be low, so the isobar will move the north, and vice versa in the winter time. Now let us first look at the factors that affects the velocity and direction of the wind. Thereafter, we will be looking at the general circulations of the atmosphere, velocity and direction of wind. As we have read that wind moves from the high pressure to low pressure area. So the first and foremost factor for the velocity of the wind will be pressure gradient force, that is PGF. How does the pressure is changing with respect to the distance? That is, if isobars are closely placed, then the pressure is changing very rapid pace, so the movement of wind will be high. That is, high velocity wind will be there in case of closely placed isobars. We will have high velocity wind, and if the isobars are loosely placed, okay, there is distance, then it will be low velocity winds. Second one is frictional force. It affects the speed of the wind. That is, near the surface, it will be the velocity will be less. Why? Because the frictional force from the surface of the earth will be applied on the wind blowing, and in the air the wind will be blowing freely. Friction. Third one will be Coriolis force. So it is a force which is applied on a body. Why? Because moving body on the earth's surface, because of the rotation of the earth. So it depends on various factors, such as if a object is moving with high speed, then the Coriolis force will be more, and at the equator it is absent, and at the poles the Coriolis force is maximum. And due to the Coriolis force, we observe the deflection of wind, such as in the northern hemisphere the wind deflects towards its right, and in the southern hemisphere it deflects towards its left. This Coriolis force applies perpendicularly to the pressure gradient force, and in the upper air this Coriolis isobars become straights, and Coriolis force and PGF become cancelling out each other, so the winds blow parallel to the isobar. These winds are known as geostrophic winds. Now moving on to the general circulation of the atmosphere. As we have studied these low pressure and high pressure belts on the earth's surface, they are the major cause of formation of the general circulation on earth's surface. This is V2. From the subtropical high, the wind blows from high to low. These are known as trade winds. They are blowing from the east, so they are easterly. Next one is moving from subtropical high to subpolar low. Westerlies are blowing here. Westerlies. From polar high to subpolar low, these are polar easterlies. Similarly in the southern hemisphere. Now this equatorial air rises from this equatorial high and moves in both direction and subducts at subtropical high pressure. So this is a convective shelf which is formed at between this subtropical high and equatorial low, which is known as Hadley cell. Now from this subpolar low, the air ascends and descends at subtropical high pressure and polar high pressure. So this convective cell between the subpolar high and subpolar low pressure and subtropical high pressure, it is known as Ferrel cell. Ferrel cell. And this last one between the subpolar low and polar high is known as polar cells. So these are the permanent winds or general circulation of the earth. Now there are also seasonal winds like monsoon. There are also local winds which are due to the variation in local atmospheric conditions. These can be like sea breeze or wind breeze. Sea breeze, that is wind moving from sea towards land. This is sea breeze, generally in daytime, and in the night time the wind moves from land towards the sea, which is known as land breeze. Another type of winds are mountain and valley breeze. Which is also known as katabatic and anabatic winds. That is they move from mountain towards the valley, and they move from valley towards the mountains. Now comes the phenomena of air mass. Air masses. What are these? These are the column of airs which have very homogeneous temperature conditions. that is, the air in that column has homogeneous characteristics like temperature and humidity. So the region from where the air mass starts is known as source region of air mass, and based on this they are classified into 5 types. That is, first one is maritime tropical, second one is maritime polar, third one is continental polar, fourth is continental tropical, and fifth one is continental arctic. And the region where the two air masses meets, this is known as the front. Based on the interaction of these air masses, these fronts can be of 3 types, that is cold front, warm front, stationary front, and occluded front. So, stationary front is the front in which the both front approaches each other and remains stationary and no interaction will happening. This is known as stationary front. In the cold front, the cold front will be moving towards the warm front and intruding into the warm front, and the warm front will be uplifting, and this cold front will be intruding towards the warm front. And in the warm front, in this also warm front is uplifted, but in this the warm front is moving towards the cold front. And in the occluded front, it is basically in the dissipation stage of the front, that is when the warm front uplifts and gets separated from the surface. This is known as occluded front. Now let us look at the extratropical cyclones. Extratropical cyclones, or also known as temperate cyclones, which are associated with these fronts. So these are, as the name suggests, forming in the temperate regions, that is mid latitudes. In the mid latitudes, the cold air from the polar region and the warm from the subtropical region is meeting. So when these cold and warm air masses meet, they produces an anti-clockwise cyclonic rotation. This is cold current and this is here warm front. Due to which this warm air is uplifted and the clouds will be formed, which will cause the rainfall. This is known as frontal rainfalls. Now let us also study about the tropical cyclones. They generally develops over a low pressure area, pre-existing low pressure area, that is, and from low pressure area the wind started moving inward like this, and a eye develops in the center and the structure develops like this. Eye, this is the eye of the cyclone. This is eye wall. From here wind rises in this fashion, in the center it subducts. So the eye is the area of calm winds. Here weather is, temperature is higher, and in the eye wall there is high rainfall and cumulonimbus clouds are developed here. Now remember, the movement of the cyclones is anti-clockwise in northern hemisphere and clockwise in southern hemisphere. And for the anticyclones, that are opposite of the cyclones, that is high pressure at the center and wind is moving outwards. This, for this, the direction in northern hemisphere is clockwise and in southern hemisphere it is anti-clockwise. And these tropical cyclones are known by a number of names such as cyclones in Indian Ocean, and hurricanes in Atlantic, typhoons in South China Sea, and willies in Western Australia. Now let us look at the difference between these tropical and temperate cyclone. Temperate and tropical. So the area, it covers a larger area, whereas it covers a shorter area. It can develop over both continent and oceans, while it develop over the sea surface, where the temperature is higher, generally around 27 degrees Celsius, and it dissipates as it enters the continent, which is known as landfall of cyclone. Time period, so generally they have a lifespan of 15 to 20 days, and they typically exceeding 1 week. They are more destructive, less destructive. And the movement of direction, as they move under the influence of westerlies, they move from west to east, and they move under the influence of trade winds, so their movement of direction is from east to west. So this is all about these cyclones. Now let us moving on to the world climate, which is majorly discussing about the Köppen's climatic classification. So he used the vegetation and climate as the criteria for dividing the climate of the world into different categories. So he provided 5 major classifications, that is A, B, C, D, E, in which A denotes tropical region, where the average temperature for coldest month is 18 degrees Celsius or higher. B denotes the dry climate, where potential evapotranspiration exceeds the precipitation, that is transpiratory losses are more than precipitation. Third one is warm temperate. Here the average temperature of coldest month, lies between -3 degrees Celsius to 18 degrees Celsius. D is cold snow forest. Here the average temperature of coldest month is -3 degrees Celsius or below. E is the cold climate, where the average temperature of all months is below 10 degrees Celsius. And there is also one criteria which is denoted by H, which is known as highland, cold due to their elevations. Now out of these 5 categories, 4 are based on the temperature and 1 is based on the precipitation, that is B. This is based on precipitation and other 4 on the temperature. And based on the seasons in which the rainfall happens, they are further divided into subcategories by small letters like F, M, S and W. F is rainfall throughout the year. Rainfall throughout the year. M is monsoonal rainfall. S is summer dry, that is rainfall in winters. And W is winter dry, which is rainfall in summers. And this B type of climate, this is dry climate, is divided into 2 categories, that is S and W. S1 is for steppe or semi-arid climates and W is for deserts. Now let us look at the classifications. A is tropical humid climate and it is subcategorized into AF, AM and AW. AF is tropical evergreen. It is tropical evergreen, like examples Amazon basin, Brazil, equatorial evergreen forests are there. AM is tropical monsoon climate, like India, South America, Northern Australia, these all come under this tropical monsoon. AW is tropical wet and dry, where winter is dry and summer rainfall happens. This example includes the adjoining part of this tropical evergreen forest, subtropical areas. Then comes the dry climate, subtropical steppes, BSH. BWH is desert in the subtropical areas. BSK, it is mid latitude steppes. This is mid latitude deserts. C for the temperate climates, it is CFA. It is humid subtropical region. Subtropical region where the rainfall throughout the year. CS is Mediterranean type of climate, where the summers are dry and rainfall is in winter. Next one is CFB, which is marine west coast climate. Rainfall is throughout the year but summers are warm and winters are also not very cold due to the moderating effect of the sea. It includes the area of west coast of North America, California, South Chile, New Zealand, Australia. Next comes the dry snow forest climate. First one is DF, humid continental, that is no dry season is there. So it is the area where the rainfall occurs in summer and winter both. And next is DW, that is winter dry, rainfall occurs in summer only, the subarctic region. Next is cold climate, which is divided into 2 types, tundra and polar ice caps, that is taiga. Tundra is denoted by ET and polar ice caps by E and F, and highland are denoted by letter H. Now let us look at the climatic classification of India. So this AS is Mediterranean type of climate in Tamil Nadu region where the rainfall occurs in winter season. AMW is monsoonal type where the winter season is dry. This is western coast of India. BSHW, it is steppe type of climate which is central India majorly. And AW is tropical savanna type, that is tropical wet and dry climate. And this Indo-Gangetic plains, Bihar and northern part of MP, it comes under the monsoon type with winter dry, CWG. BWHW, it is hot deserts, which is Thar desert of Rajasthan. BSHW, it is also prevalent in this Gujarat region. And E comes the polar type of climate, and ET is tundra, which is here in DFC, it is the cold humid winters with where summers are short. This is in Sikkim and Arunachal Pradesh. So this is the climatic regions of India according to the Köppen scheme. Now this is all for the video. If you have any suggestions, mention in the comment section. And if you like the content, hit the like button and subscribe the channel and share with your friends. We will meet in the next video. Thank you for watching.